36. Which of the following compounds is the least reactive when added to aqueous sodium hydroxide? A. NaHSO4. B. H2SO4. C. H3PO4. D. HCl. The correct answer is C. H3PO4. Explanation. Strong acids like HCl and H2SO4 react vigorously with sodium hydroxide, but H3PO4 is a weak acid, meaning it doesn't ionize completely, so it reacts slowly or weakly. That is why it is the least reactive among the options. Question 37. The hydrogen ion concentration of a solution whose pH is 3.7 would be A. 2 times 4 to the power negative 4 mole per dm cubed. B. 2 times 10 to the power negative 4 mole per dm cubed. B. 2 times 10 to the power negative 3 mole per dm cubed. C. 2 times 10 to the power negative 1 mole per dm cubed. D. 2 times 10 to the power negative 2 mole per dm cubed. The correct answer is A. 2 times 10 to the power negative 4 mole per dm cubed. Explanation. Remember the formula that pH equals negative log of the concentration of hydrogen ions. So that means hydrogen ion concentration will be 10 to the power negative pH. So now that we know the pH to be equal to 3.7, we can have the concentration of the hydrogen ions to be 10 to the power negative 3.7. So to calculate this without a calculator, we can think about it like this: 10 to the power negative 3.7 equals 10 to the power negative 4 minus 0.3, because 4 minus 0.3 is the same as 3.7. okay, so this will give you the same base, which is 10 to the power 0.3, positive 0.3, because negative 1 times negative 0.3 will give you positive 0.3 times 10 exponent negative 4, because negative 1 times positive 4 will give you negative 4. Now think about common log values. Common log values, we know that log 1 is 0. Log 2 is approximately 0.3. Log 3 is also approximately 0.48. So if you look at this, we have 10 to the power 0.3, which will be log 2. okay, so this is approximately 2 times, and then you add this section, times 10 to the power negative 4 mole per dm cube. So this is your answer. Like I said earlier, you can do this with a calculator. and then you get the same answer. One key hint for you to remember is that the lower the pH, the more hydrogen ions you have. Question 38. What will be observed when copper sulfate is placed in an iron container and left to stand for several days? A. The color of the solution changes from green to blue. B. Part of the container is coated with copper. C. Some iron particles are formed in the solution. D. Copper sulfate changes to black copper oxide. The correct answer is B. Part of the container is coated with copper. Explanation. Iron is more reactive than copper, so it displaces copper from copper sulfate solution. The iron dissolves and copper gets deposited like a stronger player taking the spotlight. Question 39. The toughness of rubber is increased by the addition of A. Silicon, B. Ethane, C. Carbon, D. Sulfur. The correct answer is D. Sulfur. Explanation. Sulfur increases rubber strength by forming cross links between polymer chains. This process is usually called vulcanization. So imagine sulfur as tiny bridges holding rubber together, so it stretches and bounces back without tearing. Question 40. The planar shape of BCl3 molecule can be explained in terms of the A. sp3 hybridization of boron, B. sp2 hybridization of boron, C. sp hybridization of boron, D. sp hybridization of chlorine. The correct answer is B. sp2 hybridization of boron. Explanation. According to valence shell electron pair repulsion theory, if there are 3 electron domains, hybridization is going to be sp2. Explanation. The Lewis structure for BCl3 is this. You have boron in the center bonded to 3 chlorine atoms with the valence electrons of chlorine on the chlorine atoms. So this is the Lewis structure for BCl3, and since it has 3 bonding domains, i.e. boron is bonded to 3 atoms, and there's no lone pairs on the boron atom. Hence, the hybridization, according to valence shell electron pair repulsion theory, is sp2, leading to trigonal planar shape. Trigonal because the shape of BCl3 is like a triangle, and the angles between the atoms will be 120 degrees.